Okay, so today we're going to talk about keeping modern cloud workloads and corporate services safe. I mean, I will try to represent the experience of Cloudflare. It's like what Mariam mentioned, how did we build it from scratch, like what challenges did we get, and like how a modern infrastructure protection should look like. So a little bit about myself. I do Linux at Cloudflare. I do operating system development, internet scale infrastructure for more than 10 years. I like operating systems, infrastructure security and performance, and I enjoy low-level programming like Linux kernel drivers, bootloaders, and stuff written in unsafe programming languages. So yeah, but today's talk about protection and protection infrastructure of the internet. So today we're going to talk about distributed attacks on the internet. And let's kind of like be on the same page as what is a simple denial of service. So this is a simple denial of service. Imagine you have a service or a server on the internet, and you have some users, right? So users access your service to get some value, right? Then you can have an internet adversary who comes in and starts sending a lot of malicious, or not malicious, just junk traffic to your service. And basically, because it all works on computers, computers become overloaded, your server becomes overloaded, and your service is not available, and your users do not get value anymore, right? Pretty simple, right? So what do we do in this case? Usually, so we try to put a firewall in front, right? So we try to build some firewall which will block our attacker, reduce the load, try to filter out the junk, right? And make our users happy. Similar, right? So, but now this is like a simple denial of service. Like, what is DDoS, like the second D? It's a distributed denial of service, which is the most popular attacks on the internet now. So yeah, you kind of work like that, but at some point there are more attackers and coming in, and like your firewall doesn't catch up. So again, your service is overloaded. So what do we do in this case then? So, well, we can hide the server from the internet, right? And nothing, but it's not very useful, right? Because you don't service it. So, but like you hide it in a way, you put it in front of a bigger dedicated firewall, right? So in the first denial of service case, like probably your firewall was your basic operating system firewall, something you configure, your administrator can configure for you. But now you say like, okay, this will be the box that will be the service, and in front we'll put a dedicated firewall which will protect us better. The problem with this approach is that eventually you get more and more attackers, right? And your firewall still gets overloaded because there is a lot of junk coming into you, and at this point you don't know what to do, and you in the old days, which I'll be speaking later in this presentation, we'll check Google, but in the new days, you'll probably ask AI, what should I do in this case? And or some people will find you and say like, hey, we're a company which sells like hardware for efficient DDoS protection, right? So they will sell you a box, and I will not name brands here, but like different brands exist out there that companies who are specialized in network equipment, they usually have these dedicated boxes that you can buy. They're quite expensive, but they kind of like do the job, right? So like they say, like, if you put this box in your data center, you're fine. However, eventually it's not fine because you get more and more and more and more attackers, and even that box becomes overloaded, right? So and your users still become. So what's the problem here? The basic problem of people forget about the word distributed, right? So the problem is how the attacker scales the attack versus how you protect, right? And the usual why distributed denial of service attack happens when somebody finds, for example, a vulnerability in a very popular IoT device like your home routers, which are spread across or like smart fridges or whatever, and it's spread all over the internet, and attackers are able to start remotely controlling these devices. So they kind of scale their capacity horizontally, so they acquire more devices almost at zero cost, because they're just like finding new devices available on the internet. The problem with you is like you scale your defense vertically, right? So you try to put a more powerful box, and in the long run you will always lose the race, because there is a limit to your scaling, and there is a high cost of scaling vertically versus the attacker's cost is cheap and scales horizontally. It's very much similar to conventional wars, right, where attackers and defenders are. The efficiency of in the long term is determined by how much money can you spend on doing the attack or the defense. So yeah, some takeaways. If you miss the rest of the presentation, this is one of the most important takeaways. The adversary will always scale the attack horizontally, and if you go with using hardware security boxes, you will go the path of scaling vertically, right? And you will always lose that race. So this is what we realized in the early days of Cloudflare, that to efficiently protect from the global distributed attacks, you need a global distributed descent. And this is why we started building out this huge distributed network that we have today. When I joined, we used to have like 20 data centers. Now, I don't even know how many data centers we have. We start counting them. We have cities now. We count like 330 cities, but a city may have one or more data centers. So it's a lot of data centers, basically. Yeah. Okay. Yeah. So 550. So yeah. So don't fall into the trap of using hardware security boxes to protect from DDoS attacks, because you will lose that fight eventually. So how do we do that literally? Anyone here familiar with network addressing? Yeah, a little bit. So do you guys know what is unicast? Unicast is a network addressing you're used to, right? So you have a server, it has an IP address, right? And when somebody needs to access your server, they eventually find you by IP address, right? So like, and your IP address is unique on the internet. This is like a familiar scheme, right? So how do you scale that scheme, right? Because you have a server with one IP address, how do you scale horizontally? And in the traditional database design, you kind of use unicast with load balancing. So instead of server, you have some load balancer, right, with the unique IP address, and then you kind of get more capacity by having one or more backend servers. So like the traffic comes into the load balancer, and then you like shed the traffic between three servers. And then you can kind of scale horizontally by adding more backend servers. The problem with kind of this approach is it's very similar to, you still have this load balancer as a single point of failure, right? It's very similar to that dedicated firewall, so it can be overwhelmed. In Cloudflare, from the beginning, like we adopted a different addressing model called Anycast. Anyone familiar with Anycast? So no? Mariam should be familiar. So Anycast is different. So we have a lot of servers across the world, but these servers have the same IP address, right? So it's not unique. So we have servers across the world, and each of them has 1.1.1.1. So how does traffic get there? And it actually happens naturally. So if a user tries to access our service and tries to access to 1.1.1, the user's traffic across the world will be distributed. So, and we didn't do anything special here. It's a natural property of the internet. So if you try to access the service, internet guarantees that it will route your traffic through the internet to the closest location. So, and in this case, Anycast kind of works, because if this is like United States, this is London, and this is like Latin America, users with and they announce the same IP addresses, users go to local things. So it's like, you don't need special equipment for that. It's the way how internet works. And the nice property about this is the same happens with attack traffic, right? So like if an attacker tries to attack us, they cannot attack a single location. Due to the natural properties of the internet, its traffic is distributed across all of the data centers. This is kind of like a map of our cities. I think it's even old now, but doesn't matter. Like, yeah, so in this case, this is what we built kind of now. So imagine all this traffic across the internet, like distributed to all these locations. So yeah, both user and attack traffic are distributed all over the world, somewhat evenly, right? And again, we're using the natural properties of the internet, so there is no need to special security hardware. And we can like scale the scheme horizontally indefinitely, right? And we just have incremental costs in adding more capacity to more traffic. One of the other disadvantages of a dedicated hardware box is like when you need a more powerful box, you need to throw away your previous box, right? So you kind of lose the sunk cost, but we never lose that cost because we kind of incrementally adding capacity when we need it. And this horizontal scaling not only allows us to handle larger attacks, I think we keep publishing, there are reports that we keep hitting more and more and absorbing bigger and bigger attacks. But we also, like as a natural consequence of that, we can also service more users because we just have more capacity, right? Cool. So now let's talk about internet hijacks. So who knows what is the internet? How internet works? So internet is one of the probably, I think it's almost the only successful example of a fully distributed system, right? So we see blockchain, but it has something. So the internet is network of networks. There is no central location of the internet. But these networks have designated numbers. So called AS stands for autonomous systems. So I don't remember, so like AS13325, I know that one, this is Cloudflare network. So, but every network has its designated number, like Google, Meta, Amazon, telco providers. So, and these networks continuously exchange traffic between each other. So we exchange traffic. But the question is, let's say, Cloudflare owns the 1.1.1.1 service, right? If someone on the internet tries to access a service on Cloudflare on 1.1, how does the internet know that 1.1.1 is in our network and not in anyone else's network? So internet uses a very old protocol still. So these networks continuously exchange IP addresses. It's via BGP, Border Gateway Protocol. So like each network continuously announces broadcasts to the world, shouts which IP addresses it's on, right? So like if like Cloudflare, this is our like one of our IP address ranges, and then so Cloudflare keeps shouting to the internet that we own 1.1.1.1, and like all networks listen to these announcements, like, oh, my user wants to access to 1.1.1, so I will send that traffic to the Cloudflare network. But the problem with this approach, because I mentioned the protocol is very old, it was designed when the internet was born in like 70s, it's a little bit of a gentleman's agreement, right? So like, hey, if you own this IP address, announce it, right? If you don't announce it, like, right? And then there is a problem of like, what if we have a malicious actor on that system who starts announcing IP addresses that they don't own, right? So like, we own this IP address, but someone else, some other network starts announcing that IP addresses, and this is where you get an internet hijack because the other network starts listening to that announcement, and if it has a lower metrics, that is like it seems closer to than our IP address, then the traffic will be routed there, and then there we have in best case you just have a denial of service, because if I try to access 1.1.1 but that network cannot serve it, like I'll just get an error. In worst case, if there is no security, they can even like pretend that they're 1.1 and do harm, right? So how do you solve this problem? Recently, networks, and we try to push every network to actually adopt it. So we started adopting a thing called RPKI. So, and what it basically means, it's an addition to the BGP protocol where these announcements become signed. So there is an upfront known database of cryptographic public keys which are owned by network, and every announcement that is made by the network is signed. So basically the other networks which listen to those announcements, they have the ability to verify that this announcement is legit, and they can reject the announcement which is not legit. And it helps also like to block the attacker this way. The problem with this is it's a two-person relationship, right? Like not only your network has to adopt that protocol improvement to start signing your announcement, the other networks should start verifying the announcement and reject. And unfortunately, not every network does it still, but more and more networks start doing it. And it also actually helps internet reliability, because these bad announcements are not even always malicious. Sometimes some network administrator misconfigures a network equipment, and you have unintentional hijacks, right? But if you basically, and some portion of the traffic is backhauled, and there are some record of incidents which happened like that in the Cloudflare blog post if you're interested. But basically, adopting this technology ensures that it's not possible, right? As I said, but not all networks do that. So we actually developed a web tool called Is BGP Safe Yet?, where you can actually go to that website and it will test your network, the one that you're currently in, if it's implementing this RPK properly. So it will, Cloudflare will start announcing invalid IP addresses and see if your network actually accepts them. So on the right, we have Cloudflare network, which we do implement this, so it's good. On the left is my home broadband provider, which unfortunately it doesn't, so yeah. But again, from your perspective, if you're planning to deploy a web scale service and you're starting to think which providers to use, make sure you check this. So your service will be much better if it operates on the safer network. Now let's talk about CDN bypass and egress tunnels. So Cloudflare started as a CDN. Who here knows what a CDN is? Content delivery networks, right? So a CDN is basically, it adds protection and the speed up of your website. So again, you have your web resource, you put it behind a CDN, it can be Cloudflare, anything else. And users do not access your service directly, they access it through the CDN. So if a user wants to access a resource, they access a CDN, and the CDN can, if it's a legitimate request, it can either cache the request or even route it back to you if it's not cacheable, right? But also because the CDN starts sitting in front of your service, it can provide you with added features. And as I said, one of the features is speed improvement, because some of the popular resources get cached on the CDN, so you don't have to always receive all the traffic from all the users. But the protection part is when you have an attacker traffic, your CDN, if it's a good CDN, should actually block it, right? So it should not send you that. It should detect it and not send you the bad traffic. The problem with that approach is with this architecture, it's a traditional CDN encryption. Your service is still accessible over the internet, and that's how the CDN connects to you. It has a public IP address. So, and that's why if you use a CDN, it's very important that your public IP address becomes a sensitive information. So you never expose it widely to the internet, and you only allow your users to access it through CDN. Sometimes it's not always possible, because, for example, if you have an API server or something. Sometimes you don't want it to go through the CDN, and sometimes you can just misconfigure your CDN to accidentally expose your real IP address. And if the attacker knows that IP address, they don't have to go to your service through the CDN and trying to attack the whole Cloudflare network. They can just go around and access your service directly and break it, right? So like CDN will not help you in this case. So what do we do in this case? Well, what we can do is, well, don't run your service on the internet. Yeah, which is not very useful by its own, but what you can do, you don't have to have a public internet routable IP address to be online. What you can do, instead of like, it's a traditional home router setup where, you know, like you have your Wi-Fi router, but actually your computer doesn't have a public internet IP address, but it still can connect to the internet, so it can establish outgoing connection. And this is kind of the same thing. So your service does not have to have a public routable IP addresses. It can establish outgoing connections to the CDN. So it can establish a tunnel to the CDN, and in your firewall, you can just reject any incoming traffic. And what will happen is when your users, legitimate users, access your service through the CDN will use that established connection to route the traffic back to you, right? And it will obviously filter the attacker that tries to access your service through the CDN. And the nice thing about this attacker, because you don't have a public routable IP address, the attacker has actually no good means to bypass the CDN and access your service directly, because it has no internet routable way to reach it. Cool? So this is kind of like a small summary what we employ to protect from global distributed attack on the network layer. But one thing you notice here that, except this case, we don't actually filter traffic anywhere, right? So our global, like Anycast, there is no filtering here. We just try to shred and slice and dice traffic, and not allow it to overwhelm one single location. But there is no filtering here. So now let's zoom in. So all these points are data centers. Now let's zoom in what we do in a specific data center. So in data center, we have a different set of things. So again, from this picture, we see that a data center may both receive good and bad traffic. So a portion of bad traffic still goes into data center. And yeah, again, you can use the traditional load balancing setup, that you can have a load balancer and scale data center horizontally, but it's prone to error because you're creating a single point of failure, which is basically a load balancer. Obviously, you can buy a dedicated and expensive load balancer, but you will fall into the trap of scaling vertically. So what can you do in this space, and what we do? We don't have, again, we're very against dedicated hardware boxes. So we just use regular equipment. So we just use regular top-of-rack switch or router or whatever, like regular router equipment you already have in the data center. But instead of load balancing, what we do is we use a thing called ECMP. It's called Equal Cost Multipass Protocol, which is essentially a data center level implementation of Anycast. So even inside the data center, each of our servers, we have public IP address configured not on the entry point, but on each of the server, and each of the server keeps announcing these IP addresses to the router. And the router basically processes these announcements, and okay, at this point I have like 3 servers able to serve 1.1.1.1, so it will basically switch incoming traffic between these servers, and it happens on layer 2, so it's very fast. So it doesn't do any processing at all, so it just shuffles as more traffic. And this scheme is very easy to scale horizontally because, well, basically, if you need more capacity, you just add servers, and they start announcing. So you don't even need to reconfigure router at this point. So you start announcing more servers to the router, and router like automatically reconfigures its table to start shedding more traffic across 5 servers. And it's also very, very convenient for maintenance, because Again, I don't need to reconfigure anything on the router to put a server into maintenance. So if I need to maintain this server, I just power it down. It stops announcing, so the router stops sending traffic. Very easy, very maintainable, and very scalable. Cool, right? So server level protection. So again, in this schema, yes?
Sorry, just a quick question. First of all, do you leave like at first packet, whatever you use, so come to one server?
We do care, and this is a good question. So yeah, the underlying trick is there that you have to send flows to particular server, right? So you don't really care if it's a UDP traffic, but for the traditional web traffic, which is TCP or HTTP over TCP, you have to send the whole flow to a single server because the server maintains the connection state. So there are different configurations of eCMP, but we use, like a CMP is called with consistent hashing. So depending on the packet header, the router will always send like the source address, source port, destination address, destination port. Based on that information, it will always send the same packets to the same header. So like the connections are distributed evenly, but one single connection always goes to a single server, except in the very rare cases, again, when you drop a server, so you start announcing, so the table is being rebuilt. So some small amount of connections are being terminated, but that's not really a problem, big problem for HTTPS because it kind of reestablishes very well. But yeah, but to keep the flow, stickiness of flow, you need eCMP with consistent hashing. And basically all routers implement that. Yeah, so now let's go down to server level protection. So again, in this schema, there is no filtering. Again, within the data center, we're slicing and dicing good and bad traffic to amount of servers, right? So like, where is the filtering happen? So anyone familiar with Linux here? Yeah? You know what does this do? It's a firewall rule, right? So yeah, your server receives good and bad traffic. You want to filter it out. This is a firewall rule on Linux that blocks all incoming connections. Right? Is it effective? Probably. Is it useful? No, because you don't receive any connection. But is it effective? It's actually not even very effective. And the problem is that we proved on practice that if you have a large amount of traffic coming into a server, even if you like block all incoming connections on firewall, you can still overwhelm it. So in this case, yes, this is our server, and we see good and bad traffic, and imagine you want to block everything, so like deny every incoming connection and good ones as well. The problem, there is still a lot of happening under the hood. So when a server receives a packet from the network card, well, the network card is the thing that receives the packet, right? So it's a network card on your server. The way how it works internally, it will send you a hardware interrupt to the main CPU and send the packet to the driver in the operating system. I mean, I'm embedding this on Linux, but it's kind of the general operating system design, right? So what will the driver do is, it will do, like at least in Linux, it will allocate a piece of memory. It's called SKB, socket buffer, which is an internal representation in the kernel of the packet. So it's the packet data plus some internal structures. It will copy the data from the NIC and again re-enable interrupts, because if you get an interrupt, you need to re-enable them back so you get more packets, right? So after the driver does it, it will pass it to your operating system layer 2 implementation, right? As an SKB structure. And what layer 2 will do, it will pass layer 2 headers, the packet MAC addresses, like, oh, if this packet actually belongs to that server or not. It will calculate the checksum of the packet. Sometimes there is a performance optimization that consequent packets, if they're part of the same flow, it will try to merge these so like it can process them more efficiently into one. So something will happen, right? And eventually it will pass it to the network layer, which is your layer 3 implementation. And in layer 3 implementation, it will pass the layer 3 headers like IP addresses. So if it's a local packet, it will start processing. If your server is configured for routing, maybe it should route it somewhere. it will do a thing called GRO, generic receiver float, connection tracking. It will check layer 3 checksums, do routing, and then it will see, oh, you configured the drop rule, and it will drop the packet. So with a large amount of traffic, you still do a lot of stuff just to drop the packet. And we proved that for specific, if you send too much of it, you can still slow down server that it becomes unusable, even if you block all incoming connections. So what do we do here efficiently is we actually spearheaded and adopted this technology called XDP, Express Data Pass. It's a Linux-specific technology, but it's open source. So again, we are against specialized network cards and everything. It's available. So operating systems, yeah, this thing allows you to inject small eBPF programs, like computer programs, early in the packet receive pass, and it's very fast. It's programmable, so you can you're not limited to what your firewall language is configured. You can configure almost arbitrary rule in packet processing, examining every byte in every position. eBPF is safe, even though it works in the context of the low-level hardware. The whole programming language concept it's not a full programming language, so you cannot really do bad stuff. You cannot write a bad program which will crash your machine. Like the language and the framework does not allow you to do it. So if you even make a mistake, it's okay. Yeah, and it's surprisingly for Linux feature has good documentation. So. So yeah, so how it works eventually it allows you, and there are two types of these programs. So again, you don't have to have specialized hardware for this. So if you don't, it allows you to insert these programs filters here, right? So like before all this, and more and more vendors actually adopted that technology. So it's not specialized like all the generic network, most of the generic network cards now support it, so it allows you to even install programs in the NIC itself. So you create it on the computer, but it's doing processing on the network interface. So in this case, this is where if you start filtering the traffic here, you kind of like don't do all this extra work just to drop the packet. And because it's very flexible, you can kind of design these programs to be very targeted and specific to target this malicious traffic very efficiently. Obviously, there is a lot of different malicious traffic. So in Cloudflare, what we did is we kind of built a whole distributed traffic filtering pipeline around this. So we have all these data centers across the world, and they continuously kind of send sample traffic to a centralized location where we kind of see a global internet network view of things, and we analyze them for malicious behavior. And when we detect that a particular type of traffic is bad, we were able to generate these small targeted programs and quickly distribute them back to all the data centers where they're filtered. Yeah. But we also learned that sometimes it's not even fast, and even this system is not fast enough. So over time, we also deployed the localized version of the service, so you can actually do some small pre-processing on the data center itself. And recently, we also learned that here is the magic word, it's a very nice place to put AI in, right? So because when you have this analysis of something pipeline, AI does a good thing. But the problem, the learnings from that, you cannot, because AI by itself is not very fast, at least today, right? You cannot directly put it to filter the traffic. You have to still build a whole architecture and use these techniques. So AI decides a strategy of what traffic is bad, but specific implementation should be really fast. And so AI decides the rules how to fill the traffic, but the rules are executed with a different technology, right? And this kind of systems allows us to have very nice properties, because first of all, if we have an attack in some data center, this local instance can quickly learn about it and block it. But because we have this small feedback loop, we automatically start blocking this traffic in all other data centers. So, do you know who this is? Any Star Trek fans? So in Star Trek there is a Borg race, which is my favorite. They're evil, but the nice properties that they have, if you attack one from their race, their kind of global collective mind, everyone else knows how to protect from this attack. So like I like to think of Cloudflare network as the Borg, but we're not evil, okay? Okay, so this is where we filter traffic, right? Okay. Now, and we've been talking about the application level protection, the network level protection. What about the application level protection? So it's not new-ish, but it's a real screenshot from my work email, from the spam directory, luckily. So I have one M1, I received an email, right? And if I open it, well, if I click on it, Google nicely tells me that this seems dangerous. There is my PowerPoint presentation, which probably if I click will infect my computer, right? So it's about malicious content, right? So this is your laptop or computer, and you may have different programs running, or like mostly it's web browser sessions. So if you click on that link, the best thing that can happen, your browser session becomes infected. The worst thing that can happen, depending on the attack, your other sessions might be affected, and all your computer will be affected. So depending on what the attackers found, there are like vulnerabilities in all systems and browsers, operating systems. If they're able to exploit it, they can get persistence. So, and probably if you work for a company, people tell you not to click on links, but even the smartest one fall for that. So what's the real solution here? The real solution is don't run any programs, right? Which is not very useful. So what you can do is you can run your programs in a sandbox, which is a hit or miss, because I know the operating systems, and it's always a constant race. So like in Linux, there are different types of sandboxes and protections, and there are different attacks trying to escape these sandboxes, and it's a constant race of what we design and how the attacker gets away, right? It's very hard to maintain. The more kind of like solid solution is, as I said, don't run anything on your computer. But if you do need to run anything, don't run it on your computer, run it on someone else's computer. And what we allow you to do is you run your browser sessions, which are not very trusty, remotely, right? So run it on our server, and our server creates these dedicated, isolated sandboxes or VMs where you can actually run your browser, and we use it internally as well. So now I really don't care about this. I can click all the links I want, and even if I click a bad link, so that session will be internally infected, but eventually when I close it, it will be destroyed and nothing will happen. Cool. So the final piece, it's kind of new. So let's talk about content protection. And some of you may heard from our CEO, like a lot of interviews, but I tried to repackage it in a more accessible way, I guess. So who knows what is 42? Yeah, it's the answer to everything. Nice. So, but for those who don't know, what would you do to find out what is 42? Like in the old days, you'll probably go to Google, right? And you'll still go to Google and ask it, what is 42? But what happened before? Before you would see something like this, right? So you'll see like search results, and someone made a good website about what is 42, the meaning of light, and it will reference to Hitchhiker's Guide to the Galaxy, right? But still you don't have a lot of context. So what you would like to do, you click on it, right? And then you access this website, and somebody nice maybe made a good overview of the book or of the comics or whatever, right? What do you get now? You get this, right? So you get an overview, and it will tell you exactly what you need to know. And if you click on show more, you will see like 3 paragraphs of text explaining in detail where it comes from, all the and the chapter from the book. It will tell you everything. So yeah. We have a public service which everyone can use for free called radarcloudflare.com, which exports many measurements of the internet from the Cloudflare perspective. We process a lot of traffic, around 20% of the web, so we see a lot of nice trends. And this is like the screenshot I took like yesterday, so it keeps changing, but the thing is like roughly more than 30% of the internet traffic is bots, right? So 68 is human. Yeah. Bots for different reasons, but most of the time it's crawling, correct? So, what happened before when you're starting a new resource and you want to put it on the internet? You're starting a service, like you put content on the internet, and content with search engines work like this. So you have nice content, like or a service, and you want make it available to users. But how users will know that you have your content? So you have this bot called a crawler, right? Like Google bot, which will eventually, at some point, find your content because it crawls over the internet. It will crawl your content, so it will take a snapshot of your content, store in some database, and categorize. So when the user wants to know what is 42, user will ask the search engine, right? And the search engine, having to have your content, will direct it to your website, right? With an age of AI, it's a little bit different. The beginnings are the same. The starting state is the same. Again, you have the bot which crawls your website. The problem is when the user requests what is 42, AI just replies, right? So what we see now is you get a thing. It wasn't mentioned publicly by our leadership, but I came up with a name called denial of value, right? And it's a superset of a denial of service attack. So what is essentially a denial of service? You try to shut down someone's service, that it becomes unavailable, so you kind of lose value, like because you put that service for some reason. Either you have your real money revenue, or for example, you just make a popular resource and you put ads, so you have ads revenue, or even you just want to seem like, you know, like the best expert in something, so you put a personal website or blog and you're getting a value that everyone recognizes your name. So yeah, so like denial of service is one type of denial of value attacks, but now we see more. With denial of value means that because AI doesn't refer users to you, people just read the answer to their question, but they don't know that you're the expert in this. So you're not receiving that value, either ad revenue or a normal revenue, or even just recognition that you get. So it's a kind of superset of denial of service. And we also, on the Cloudflare radar, we publish we try to come up how to measure this. It's like crawl to refer ratio. And if you see our CEO presenting about this, he actually mentioned the numbers for Google specifically, that it was 6-1. He did mention the number, it was like before AI, so 6-1 means for every Googlebot crawling your website, every 6 times Googlebot crawling your website, you get one new user, like which knows about your website. So then it kind of jumped to 18, but now it's kind of like I screenshotted it literally today or yesterday. It went down to 6, but if you click on that, it's kind of like you see the history. So it really went up at some point, and I think they're doing something that comes down. But Google is fine. Like for Yandex, it's 21-1, right? So you have like 21 crawls just one refer. For Microsoft, it's even worse, and for real AI bots, it's completely bad, right? So like real AI bots do not like to send you visitors. But the overall gist is, even though like it goes ups and down, the overall trend is up, right? So the more AI we have, the more this metric will have, the less of value do you get. So, and this is kind of like the emerging thing that now everyone who has a service or a content on the internet should think about. So how do you address it? There is a very old, actually, standard from, it was recently standardized, but like the concept is very old, and it was a de facto standard from the internet called robots text. Anyone familiar with robots text? Yeah. So yeah, it was like, I think it started in 1994, and it's very simple in design. So you kind of declare, your website has a text file in the root of your website, which all the robots should read, and it tells you literally like which robots are allowed to access which part of the site. The reason it wasn't popular before, because the internet, the business model of the internet was different. You kind of was not, we were not very interested blocking bots, because we want as much crawling as possible to get as much visitors. Now we're kind of like, we now to be more, need to be more selective, so we want crawling bots to come through, but we probably may not want AI bots to just taking our information as is and using it not to refer users to us. And again, it was recently standardized as true internet RFC, so the number is high, but it was a de facto standard from 1994. Yeah. The problem with robots text, again, because it's an old technology, it's a gentleman's agreement, right? It's good enough to manage good bots. So it is the expectation, oh, I'll put this file in the root and robots will read it and they will tell, and they will behave as I say. Well, it's not always the case. So what if the bot is misbehaving? So you see a bot, but it doesn't, and we saw that many times, and we get complaints about that many times, as somebody using a bot on Cloudflare network, which doesn't really. So what is the bot is misbehaving? So it doesn't read the robot text and doesn't respect it. So we probably want to block it. But blocking bots is not easy, right? So like how to block a bot and not block other traffic. So the problem now is that we need to identify and authenticate bots reliably, because you still want legitimate users to facilitate. If you're, again, if you put a firewall rule, block everyone, like users do not access. So we also publish statistics like verified bots. It's a screenshot of first two, but there are like many bots in this page that like there are like legitimate bots that kind of identify themselves properly, and they also respect robot text file. So instead of doing your own research, you can just use this very easily to at least manage good bots, right? And these bots are verified by two, either one of the properties. So like the slightly outdated thing is they're verified by IP or reverse DNS. So basically the bot owners like Google, they publish that like, oh, our Google crawler or like any other bots that they maintain also for AI will only come from these IP addresses. So if you see like a bot traffic from a different IP address, it's likely not their bot, so you can really block it. So you kind of design your firewalls around it, so like these bots can only come from these addresses. Again, circling back to our previous presentation, it may be spoofed in networks with no RPKI. So if your service operates in a network with no RPKI support, there may be a malicious attacker which can spoof outgoing IP addresses, and you will be thinking that you're relying real bot, but they are not real bot. So this is where it's nice if your service is operating in a network with proper RPKI support, so you can assure that the source addresses, your network ensure that your source addresses are legitimate. And the new way of doing this is basically to decouple it from the network. So it's not a standard yet, but we are one of the companies, and like many others are working on a standard called web bot authentication. So instead of using IP addresses or network tags, right? So we use strong cryptography. So when bots, the more bots will eventually adopt this standards, when they try to access your website, and can actually verify their messages will be properly signed, so you can verify it comes from a proper bot regardless of that IP address. Yeah, and basically, if you want to use this resource, you can click on any of the verified bots, and we give like some useful information. For example, if you want to block Google bots, or like here is like the example robots text file that you can just copy paste and stuff. Yeah, but this is for good bots. What about unverified malicious bots, right? So obviously there will be more and more unverified malicious bots that will even though like good bots they still identify themselves by HTTP user agent, the malicious bot can say they're a legitimate user, and then you need to somehow make a decision that is not legitimate, it's a person, it's a real bot. So we know about CAPTCHAs on the internet, but CAPTCHAs are really, really bad for user experience. So, and again, circling back to the beginning of the presentation, where we say like to efficiently protect from distributed attacks, you need to distributed defense. I think here you need to fight the same thing with the same thing. So eventually you will have to fight bots with bots. So eventually you would have to build a whole like machine learning AI engine which can like properly categorize the traffic and identify these bots. And actually we do a lot on this research already, and we have some tricks and sleeves how to filter out bots from humans without resolving to CAPTCHAs, and we have this information available on our developer profile. It's like a JavaScript challenge. There are some heuristics and other things you can employ to actually, and then train your model to actually identify the traffic properly. But yeah, I think in the long run we will have like a bot fight mode where the attacker bots will fight the defender bots and protect your content. I guess that's it. That's what I wanted to tell today. To summarize, again, to protect from global distributed attacks, you need a global distributed defense. Don't fall into the trap. Vertical scaling will always fail eventually, and avoid single points of failure within your infrastructure, especially with AI. So AIs are slow, don't put them in the hot paths of your data flows. Like put them like as a decision makers, but don't put them in the hot path. The network is a computer now, so you cannot rely on traditional castle and moat security defenses like blocking by IP addresses or by some other network things, because the internet is your security perimeter. Users can be anywhere in the world, your customers can be anywhere in the world, they can be bots or humans, and you have to accommodate all of that stuff. In practice defense and depth, again, as I showed the way how we Cloudflare, there is no a single place where we concentrate our defense. We need to build security in every layer of software processes, like from network to application to content and everything on all layers of our infrastructure and the software stack. And yeah, the business model of the internet is changing with AI, so more denial of value attack types emerging, and denial of value is a superset of denial of service. And yeah, efficient bot management will get more important in the future, and you have, as an innovator, we probably want to track that in space. Thank you very much, and maybe if we have some more questions. Questions? Вопросы? Да.
I'm a little bit surprised by 30% that you showed in bot traffic. Do you think, well, historically, to my understanding, not very much into networking, but to my understanding, there's not really a problem with having too much bots. But what if we have way more open AIs coming there? Is it possible that we're going to have so much bot traffic that the whole unit economics of routing and the internet itself will just not work, because most of the traffic is not revenue generating traffic anymore?
Well, I don't know. I mean, yeah, and it's a good point that when we say like, oh, there is 30% bot traffic on the internet, it doesn't mean it's bad, right? It's the way how it is. So like, there are many good bots with real useful things, and I think if we keep finding ways to keep good bots and filter out bad bots,
we want to have more good bots because by definition of good, they provide some value to us, right? So, and if they provide value to us, we'll probably find ways to accommodate them in the internet infrastructure somehow. But if we get too many, I wouldn't say AI bots are bad. It's like bad behaving AI bots. We just take your content without your kind of approval or consent and deny the value that you constantly produce. That's kind of bad, right? So, but I think we will probably, if we don't protect from bad bots, we'll probably reach the denial of value content attacks faster than we reach the capacity of the internet with too much traffic. Yeah.
I've heard about the marketplace, Cloudflare building marketplace where you can register and allow to start your website.
And this is another thing I didn't mention in the presentation. This is another thing that we're working on, that you don't have to have a binary choice whether to not allow AI bots or allow bots. As a content creator, if you want to still allow AI bots but get the value, you can sell them your content, right? And we develop, it's not a new protocol, it existed before. It's in HTTP, there is a status code called payment required. So if somebody accesses your website, again, if you can identify that this is a bot, this is AI, we still need to build some part of it, right? So we can only do it for verified bots, the bots we can authenticate, but if we know it's a legitimate AI bot which came from our content, we can challenge it and say like, look, I'm not denying your access, but if you pay, I'll allow you, right? And we send a special status code like payment required, and the bot, depending on the bot implementation, if it accepts, it will reply that, yeah, fine, I'll pay you that.
Does it work already? Does it work already?
It's kind of like a prototype and beta, but it kind of works,
So in the future, like...
Yeah. I mean, I'm not sure, I cannot comment because I'm not directly related to the project and the scalability of this, but eventually it will work well. So, like I think you can opt in to try it out.
It is now in beta and we are already doing it in the US, and we participate in this chat, like I see every day when there are some requests coming, so it's better, but once it's done in the US, more or less, then it comes to Europe.
It's also like a two-sided agreement as well, like the operators of AI crawlers need to opt in, right? They need to support.
And then how the payment will go through, that's also interesting question.
Yeah, I mean, I think it will eventually improve because the way how currently now it's a post-settlement where you kind of say like, hey, pay me, you say, okay. There is even a price negotiation thing happening because when we say like payment required, you can, in that response, say like, I want this price, right? And the bot can agree. Or you can set a max price, and if the bot is configured to accept that price, it will say, yeah, I'll pay it. But it's again, it's a little bit of gentleman's agreement. You agree with the bot, you allow with the content, we'll opt it, and we'll settle the payment later. So, but what if someone said like, no, I want to pay it, right? So, yeah. Probably eventually, I know there is like, I don't know if there is a path there was a project from, I think it was Mozilla or someone, to reward content creators with micropayments, so it's like in browser support as well. Maybe that scheme could be also adopted here, where it's not post-settle, it happens on like blockchain in real time. So when you access it, it's getting recorded into blockchain, and automatically, I don't know if it's implemented by smart contracts, you get those pennies in your wallet for accessing the content. That can also be a
Cool, that's really impressive.
Yes?
Just wondering how this denial of value problem is solved eventually. Like if you allow crawlers and bots, then they will not mention you. If you don't allow them to access your site, they will not mention you anyway. So how to...
Well, it's still like either it will be solved by payments. So eventually, to be a successful AI company, you need to train your model to give meaningful responses, right? So like in this current scheme, like the way how it's implemented in Google, you get an AI overview, but you still get search results. And if that AI overview becomes useless and silly looking, you will fall back as a user to proper content, right? But I think the people who operate that AI, they obviously want you to get value from it. So maybe they will say like, okay, we will invest that you get a nice response in the AI world, but we will kind of pay the content creators directly to train our model versus like just presenting the content to the user. But either way, you as a content provider, you get that value. Either you get the user or you get the payment from the AI system.
A lot of questions can be.
Thanks all for the lecture for this year. I'm rather new to the network, so my question might be a little bit stupid. But so, this sounds like quite a lot of work done when I'm just Googling something or AI something. I primarily work with Databricks, which basically involves everything from data engineering, moving data from pods to pods. Streaming is an essential example, right? And streaming relies on a network which is stable and reliable. So with all of that that's being done to protect the network, like what is there done for the latency, basically?
So, so like RPKI, from our perspective, improves latency indirectly, right? Because as I said, routers on the internet are configured all the time, reconfigured, and automation reconfigured. It has bugs, and once in a while we get like a bug and misconfiguration, and some of the, even like a smaller amount of packets go to, we call it a black hole, right? So it's black hole. So, and it kind of reflects on the streaming latency because you don't notice it from a connection, but TCP is actually very reliable to packet drops because of all the retransmissions, but you don't see it hidden from you on the abstraction of the operating system layer. But but assuming where do packet drops come from these misconfiguration, and if you have a system that does not allow these misconfiguration to produce an effect, you kind of improve the latency of the overall and reliability of the overall solution. So the other part is the architecture itself, right? So when you say you need lower latency, it's like for different things, it means different, for different actors on the internet, it means different things. So like, so like if you move data from one part to another in bulk, so maybe you more care about throughput. If you make a call, probably you care about latency more. But then, like with calls, packet drops are not a big thing. So before Cloudflare, I actually worked at Samsung Electronics, and I made like a secure communication thing before even WhatsApp on a mobile device. And I learned that on telecom networks, on voice channels, packet drops are a normal thing, but you never notice it. Like you get like 30% of packet drops, but because of voice encode, the way how voice encoder works, it really like handles it very well, so you don't notice it. The other thing is like some users are latency sensitive to the part of it, and this is where the CDN helps. So this is why we don't use any cloud providers to provide our service, because we have a different goal. So with larger like hyperscalers, you have like big regional data centers. So like you have a Europe, like in AWS, you have a Europe, US West, US East. We don't want big data centers in single location. We want small data centers across the world. The reason is we want to be as close to internet users as possible. So what we usually say, we try to be like 50 milliseconds away from 95 internet users on the planet. So like we need to build a small data center, but because, and some of the traffic still goes through the internet, but most of the traffic is terminated at this local data center. So for users, the experience is better because they see very low latency at loading most of the website, but you still load something.
That's assuming they use Cloudflare.
We can, I think. I think we have a product even for that called Cloudflare Choose, basically. It's I'm not experienced with it myself because I work in the lower level, but it's literally a Kafka type thing, or a message bus, whatever you call it. Yeah, cool. Yes.
I haven't worked a lot with Cloudflare, to be honest. I haven't worked at all. but one of the common standards, common architecture where it sits on top of some cloud provider. I think we work with mostly all cloud providers, right, in the market. So I'm just curious how you dependent on them, because it's pretty, like what we saw before, we also sitting on that way, on top of cloud providers as a vendor for the API platform. And it's pretty common, one of the main challenge when we see when all these cloud providers, they classify and patch vulnerability software in their own way, and it's always different for every cloud provider. So I'm just curious, do you provide some service on top of them completely? Are you dependent upon them in terms of software they're patching? Yes, is it like kind of shared responsibility, or you provide something like completely on top of them?
No. I mean, for most of the stuff we have fully on-prem infrastructure. So we did have an outage recently because one of our services was using like Google Cloud, but it was only one service. But like the most of stuff we manage in-house. So like I do the patching of the operating system every week. Yeah, but to your question is how is it different? I like to say like, for example, if you consider a traditional cloud provider like Amazon or Google, they are what you would take if you take your computer and put it into the cloud, right? So you in the computer you have compute, your CPU, and you can do it on Amazon, right? And you have storage, like you have object storage like buckets on Amazon as well. Right? So you basically take compute and storage and put it into the cloud, so it becomes an elastic resource. Cloudflare is not that. Cloudflare is, what if you can still use that, but Cloudflare is your home router, right? So you take the router and so you need both, right? So you need the compute and storage, and you need router which will route you at internet scale in the most efficient possible way. So this is how it. So this is why we're different completely from the traditional cloud provider. Good.